So I'll use the PDF document to do my presentation. This is the presentation for group 2, and we were 7 members. And then this report provides a comprehensive analysis of data containing social network user information and their purchasing behavior. So we did the loading and inspection of the data set. We had to load some libraries, the tidyverse, caret, rpat.plot, and proc. And this is how we loaded the data. And we had to display the data using the structure function. And from that, we could see we had 400 observations and 5 variables. The 5 variables represented the columns, and it was user ID, gender, age, estimated salary, and purchased. This is how the first 6 rows looked like. When using the head function, this is what we came out. So the data set contains 400 observations with 5 variables, and these were the 5 variables that I've just explained. And after that, we went straight ahead to do the exploratory data analysis. And these were the outcome that came out from that. And I think it's clearly shown. And then we did a visualization. And this is the distribution of purchases. We used the ggplot. And this shows the distribution of purchases. So these are the count on the y-axis, and the x-axis are the purchases. And 0 is for those who didn't purchase, and 1 is for those who purchased. And then we also had a presentation on age distribution by purchase status. This is the code that we used, and this is the graph that was given. So this is for age distribution by purchase status. These are the counts, and these are the age. And this is the key that shows the distribution. And we also have a graph showing the salary distribution by purchase status. And this is how it looks like. And we also have for gender distribution by purchase status. And this is how it looks like. And here we did a correlation between age and salary by purchase status. I think this diagram is similar to what William had shown in his presentation. On the y-axis, we have the estimated salary, and on the x-axis, we have the age, and this shows the distribution. So key observation from the explanatory data analysis: the data set is balanced with 257 non-purchasers. Those were indicated by 0, and 143 purchasers. Purchases seem more common among older users, peaking around the age of 45 to 50 years. Higher salary ranges shows more purchases, but the relationship isn't perfectly linear. Gender distribution is roughly equal, with slightly more males in the data set. This information is clearly shown by this diagram here. We went ahead and did the data pre-processing. We had to remove the user ID column, and this is the code which helped us to do that. and we had to convert gender to a factor. And this code is explaining how you go about doing that. We had to set a seed of 123. We had to create data partition, and these were the dimension. So these are the dimension of the trained data. We had 301 data for the training and 99 for test. This was 75% of the total amount of total observations, which was 400. So if you take 75%, you pick on 301. So summary statistics for training and test. This is the function to create summary statistics. And this is the table which summarizes everything. For training, we had 301, and for testing, it was 99. These are the observations. So these are the outcomes. So we had to build two models, one for logistic regression, and the other one was for the decision tree model. So this is the code on how to do the logistic regression model. And as we know, the logistic regression model comes from the binomial family. So this is how you go about it. And this is the summary of the output that the model gave. And on the second model that we did, it was the one for decision tree. This was the code on how to go about it. And this is a diagram showing how the decision tree was done. So we did the model evaluation. I have how many minutes?
3 minutes.
3 minutes, okay. I'm trying to rush it. So we did the model evaluation and we used accuracy and LCRC metrics. This is the function to evaluate the models. This is the plot for the ROC curve. And this is the evaluated logistic regression. We use sensitivity against specificity. And this is the evaluation for the decision tree. These are the comparison. We had to create comparison table. So these were the two models that we came up with. For accuracy, these were the results. For sensitivity, these were the results. For specificity, here are the results, and for the AUC. And we had to discuss the results. The evaluation metrics showed that for logistic regression model, accuracy R-bound, this was I think the code that we used. And it shows good performance with balance, sensitivity, and specificity. This is shown here. It's for 0.875 for both logistic regression and decision tree. For decision tree, it performed slightly better than logistic regression in this case. So for our conclusion, based on this analysis, both models perform well in predicting the purchase behavior. The decision tree model shows slightly better performance metrics, Age and salary appear to be significant predictors of purchase behavior. The model will potentially be improved with feature engineering or more complex algorithms. This analysis provides a solid foundation for understanding customer purchase behavior based on social network advertisement data. The model could be deployed to predict which users are more likely to make purchases, allowing for more targeted advertising strategies. So I'll pass it over to my group members to receive questions from the class. Over to you, my fellow members.
Yeah, thank you, Stephen. Any question, Prof? You can go ahead if you have any question before the.
Thank you, Abigail. Oganga, I saw you split 75-25.
Yes.
And correct me if I'm wrong, William split 80-20.
Yes.
I had mentioned in the document that, put some references for choice of split. Did I put something like that in the document?
Yes, you did.
So why this choice of 75-25? That is number one. Then also show us something within your code. I saw it, but I just want you to refer to it. So show us something within your code that does the splitting and what you can tune or change so that it gives you, let's say, 60-40 or 70-30 or 80-20. It was there, but I'm just triggering you to just show it to us also again.
Okay, for the first question, I'll share the reference. It was there, but it was removed by my colleagues. We saw it, so I'll share it with you. Maybe in the final document that we use to submit the assignment.
Okay.
And then for the other question, let me pass it over to my colleagues so that they can also say something. I don't want to be the only one talking here.
The other able colleagues, we are waiting for you. So my question was, what was the part of, which part in your code, if you are to change it from 75-25 split to 80-20 split, what line of code are you supposed to intervene at, and what value do you need to change? Oganga, you've stopped sharing. Is my question clear?
We are
Is
waiting
my question
for
clear?
record. Okay, I want to give an input. So for this, you'd look for where the data split happens, and often it's aligned somewhere where there is a trend underscore test underscore split. That is a function. So there you can change the test size parameter from
Where is it?
0.25.
Are you the one showing?
Kindly share your screen. Let me stop sharing and then you share for a minute.
I know somebody has pasted something on the chat box.
Let me check.
Maybe we can just use what you've posted on the chat box to explain. So what is the function for splitting, and which parameter you need to change if you wanted it to be 80%? Sorry, are you there?
Yeah, I was saying that you need to change the test size parameter. So like you mentioned, you want to change from 75 split 25 to 80-20. So you can change it from 0.25 to 0.2. In that way, you'll get an 80 to 20 split.
Is Marindi part of your team? Marindi posted something in the chat box. Is he part of your team?
Yes, he's one of us.
But you are talking about different parameter. Did you use the same function, the one explaining and what Marindi has posted? Did you both use the create data partition function?
I think he's explaining how we do it in Python, not in R.
Or what,
Okay,
what is shown here is Python? What?
No, the one which is shown here is R, but the one who was explaining was giving information about Python way of splitting.
Okay, so this is the point. Okay, we all use this create partition function. And then this is the parameter you are changing. For this case, for example, it was given as 70-30. So in this case, it's just 0.7, which will take care of 70-30 split. So if you want to move to maybe 80-30, 80-20, you change corresponding. Yeah.
Okay. Just to confirm, by the way, why are we doing splitting? So why are we doing the split? Just to be on the same page with everybody.
Split your data so that you have a training set that is seen data, then the remaining will be untrained set. So it will be unseen data. So whenever you train your model on this trained data set, so you give it later the unseen data to check how it works, whether it's enough.
So basically, instead of building your model, then waiting to go and collect the data later on to test whether your model works or not, the already collected data is what you use for both training your model and also testing it. That's the reason why we are splitting. Okay.
Exactly.
I think that's all from my side, Abigail.
All right. Thanks, Prof. Any other question from the class?
What I've shared, I modified after the presentation, especially to capture Mary's comment.
Okay. I don't think I heard that very well. But James, what did you say?
That's based on what you've posted in the chat box or what?
Hello, James.
Hello, James.
I think something. Okay. All right.
Maybe proceed.
Yeah, we can proceed to the last group, group 1. Whoever is representing group 1, please go ahead and do your presentation, and you have 10 minutes. Who is representing group 1?
I hope I'm audible.
Okay, yes.
I will be presenting for group 1, and the group members will take on the questions. So let me share my screen.
Okay.
Okay, so we were 7 members listed there. Myself, Roger, Abigail, Pauline, Wambui, and Kaimba. So a lot has been said, and I'll just go through the main points. So we loaded the data set and checked the observations therein. So after loading, we checked the structure and confirmed that there were no missing values from the data set by this code here. And then we did some EDA. We did some exploratory data analysis where we explored the data to understand patterns. So purchase, most users had not made a purchase.
I don't know if I'm the one losing you. Am I the only one losing?
Sam to me. Sam,
okay,
we can't hear him. Yeah.
Andrew, please check your internet connection or something. Can you hear us?
Yeah, I can.
Okay, you're now audible. Yeah, go ahead.
Okay, so I'm saying we did the exploratory data analysis, and after doing that, there's some age distribution. We did age distribution by purchase, where we found that older individuals are the one purchasing houses. After that, also on salary distribution, those with higher salaries do make a purchase. So, okay, that is that. So after doing that, we went to data pre-processing, where we classified gender and purchase as a factor using that code. We did split the data set using that code. I think this is the same code that has been explained by the previous group. So in our case, we use a 70-30 train test split, which is commonly used in predictive modeling, offering a good trade-off between the model learning and generalization. So we quoted that book we got it from, and also we highlighted Prof class notes. We did summary statistics, and from there you can get the mean, the median. And then after that, we went to do the model building, where we did the logistic regression. So the code is there. So we didn't call out age as a factor here because in building it already we had done that. And also we did the same for the decision tree. And now we wanted to do the model. We evaluated both models using the confusion matrix. And in logistic regression, if I scroll, we had an accuracy of 86.6% there. We had a sensitivity of almost 88.3, specificity of 83.3. Okay, so after doing that, we compared ROC and AUC. ROC is AUC is area under the curve.
Andrew, we are
keep
losing
on appearing and disappearing.
again.
Okay. I think it's my network. So I was saying that we used ROC and AUC to compare it. And for logistic regression, we had AUC of 0.9165, and for the decision tree, we had 0.91113. So this shows that both models have excellent ability, with the logistic regression slightly ahead in AUC compared to decision tree. So okay, so that's that. So another question, I think now the members can take the question. My presentation is off.
Okay, thank you, John. Prof, you can go ahead and ask your questions if you have.
Thank you, Andrew, for the presentation. So in your conclusion, which is the best model? Maybe the difference is not much, but which model is it giving you to be the best?
Decision tree.
Decision tree. Okay. Then when you are setting the seed, I saw you are using 1, 2, 3. The other colleagues also used 1, 2, 3. Is there anything special with setting the seed of 1, 2, 3?
It is nothing special in setting the seed in 1, 2, 3. I think setting the seed just it replaces random numbers for that and for reproducibility.
But is it a coincidence that you are putting 1, 2, 3 and your colleagues are also putting 1, 2, 3?
It is not.
Because I mean, most books will be using 1, 2, 3, but you need to show that it doesn't matter. You can set your own seed. So you shouldn't be putting 1, 2, 3. You should try something else just to show that you understand how it works, and irrespective of seed value, basically the seed is just to allow reproducibility of the results. But repeating the 1, 2, 3, the other colleagues 1, 2, 3 shows that maybe somebody doesn't understand why we are using the 1, 2, 3 or why we are setting the seed. I think the rest are pretty standard from the others. Maybe for readability of your results, you need to be able to produce a summary table showing showing the metrics that you are using to compare the two models, rather than letting people to fish the information out of the text. So you'd rather put them inside a table. I think that's all from my side.
Thank you. That's
Thank you.
noted.
Any other questions? Any other question from the class?
I think just observation to this group, I realized like most of your course didn't have comments. So I think it's good practice to have like comments always.
Okay.
Yeah.
Okay.
Thanks, William. Maybe remember the assignment had two parts, right? The first part is this one of building the model. Then the second one is deploying the model. And what we mean by deploying the model is that you put it in a format that people can use it to make decisions. For example, now already for all the three groups, you are showing that the decision tree is coming out to be a better model compare logistic for this particular data set. Then the next thing is to deploy this such that if you have new customers, people can just come and plug in the values of the customers, then it's able to show you whether that person will do a purchase or not do a purchase, right?
Yeah.
So the next stage is deployment. Anyone who has interacted with the R Shiny? Anyone who has interacted with R Shiny? Okay, so partly maybe when you'll be doing deployment, maybe at some point you'll be required maybe to use Shiny R. So go and read out what Shiny R is about. So you can use R Shiny to make dashboards or to make interactive things or graphs using R, which can be displayed in a browser. And you can also make a dashboard where somebody can come and place in the values, let's say the age, the salary, then it can show them what is the probability that that person would make a purchase or not make a purchase. So I leave it to you to do the second part, but I just wanted to note that, R Shiny is one of the things that you can look at as you are going through the deployment bit. So I think already so far it's good work, but now when you are moving to the next stage, we all move with the decision tree. That is the model that we are going to move with to be able to deploy our model. So we are using with decision tree. So how you deploy it, the other thing that you might have seen, package are doing the same thing. Sorry, can you hear me?
Yeah, we lost you for a second.
No, somebody was giving, I mean, there was a call that was coming through. Yeah, I was saying that, as you have realized that, we can all do the same thing, but using different kinds of packages, different line of codes. But at the end of the day, we are getting almost similar results. So as we're going to deployment bit, where we'll be deploying the decision tree model, which all the three groups have seen to be the best model for this particular data set. The codes might not be the same. The deployment strategy might not be the same. I've just mentioned one, which is the shiny R, but you are at liberty to do it in a different way. Is that okay?
Yes.
Then the beauty of presentations also is that, it brings in things that even if I was to teach, I will not be able to cover those things. For example, what William brought in about, imbalance in, let's say, some data set. I will tell you for sure that if he didn't bring it up, I would never would have covered that imbalance issue using SMOT or upsampling or downsampling. We will not have covered that one. So the beauty of this presentation is that when people bring diverse information, we get to learn from one another out of this. So again, I'll request all the codes to be shared. To the so came in again. So share, Abigail, share once you collect the information from all the groups, please share with me, including the codes, because these are what I can give other students in future, that this is what other people did. Can you learn something from them? I think I'll stop there, unless there's any other comment.
Okay.
Yeah.
That's fine. I will share them. We had talked about having the cart.
Yeah.
Yeah, and my colleagues are suggesting that we do either an online cart or take away assignments because of the complexities of traveling to Nairobi to take the cart and then coming back again for the exams. I don't know if that is an option you're open to.
Let me think about it. Most likely we can have it as open book online somewhere where once I have all your email addresses, then I send you the information, then you do the work, then you send it to me after an hour. So we agree on some time limits.
Okay.
So let me think through it, then I'll see how to deliver it.
So thank you.
Okay.
And
thank you guys. And you guys, I mean, you are one of the amazing classes that I've interacted with.
You're one of the amazing lecturers we've had as well.
No, because you take your work seriously as well.
Of the class.
You take your work seriously. Some groups you'll give them this and ask them to present, and nobody will come and present anything. And you are like, why are you in the class if you're not able to do an assignment and come and present? If you're looking for a certificate only, I mean, that one you can get, but try and learn something out of it. So your group is one of the first classes that I've interacted with that is amazing. You give them and they do beyond. You guys go beyond. And you don't copy from one another. There's no element of copying from one group to the other. In as much as the codes, the packages are the same, but the way you organize your work, some people will be sweeping, some people will just be making presentations, some people will be showing the codes. It shows that you took your time, did the work, and you're able to present it. So kudos, guys. I mean, it's good work. Sometimes it's good to appreciate when students go an extra mile. Thank you so much.
Thank you as well.
Thank you.
Sure. Merci beaucoup. Merci beaucoup.